We now discuss the solution of a problem from the section Mathematical Reasoning. The problem is on the tautology. This problem has appeared in Joint Entrance Examination Main held on 24th June 2022 in the first session. The problem is the number of choices for delta belongs to the set consisting of 4 logical connectives. The first one is and, or, implies and implied by, such that P delta Q implies in brackets P delta negation of Q or in brackets negation of P delta Q is a tautology is 4 options are given. Option A 1, option B 2, option C 3, option D 4. So we have the 4 logical connectives here, and delta belongs to this set consisting of the 4 logical connectives, and a compound statement like this is given where delta is there. And for what delta? This is going to be tautology. And how many such deltas from these 4 can be obtained such that this statement is a tautology? So how many of them? Are they 1, 2, 3, 4? So let's now discuss the solution of the problem in detail. We have this given statement, compound statement, and where this delta belongs to the set consisting of 4 logical connectives. The first one is conjunction, that is and. Second one is disjunction, that is or. The third one is if then, that is implies. The fourth one implies and implied by. Now P implies Q is equivalent to not P or Q. So we apply here. We apply for this. So that is equivalent to not negation of P delta Q or this one, that is in brackets P delta negation of Q or negation of P delta Q. Let's call this as the equation 1. So this statement 1 is equivalent to the given one. So we are going to compute what is this one. Is it going to be a tautology for the delta that is belonging to these 4 logical connectives? We will discuss one by one in the next slides. So we have that compound statement, and that is equivalent to this, and the delta belongs to these 4 logical connectives. The case 1, first one, delta is equal to and. Then 1 becomes, so wherever there is delta, you write and, that is conjunction, right? So it will be P and Q or P and not Q or not P and Q. So this is 2 after delta taking this logical connective conjunction, that is and, the statement 1 becomes statement 2. Now is this statement 2 is a tautology? That's what we are going to ask. So to say this one, so if you know the truth table for and, that is sufficient. How? it will be the truth table for AND is this one, which you are very familiar. And now here we have taken P, Q, the truth values you have to write here. And the first one, not negation of P and Q. The second one is P and negation of Q. The third one is negation of P and Q. So in this, P is true, Q is true. So T. So P and Q, T and T is T. Negation of T is false, F. Now P is T and negation of Q is negation of T is F. So TF is F. And not P, negation of P is F. And Q is T. So FT is F. So this is F. So F or F or F. So that means these three, brackets you have to make R in between. So then the statement 2 becomes F or F or F is F. So once this is F for one set of truth values, then this is no longer gives a tautology. So it is not a tautology. Okay, we move on to the second one. Now those are that's the given compound statement, the equivalent one, and now the term of delta is equal to R. Then wherever there is delta, you write R, you will get negation of P or Q, R, in brackets, P or negation of Q, R, negation of P or Q. So now, if you know this R table, that is disjunction table, if you have, so which you are very familiar with this. So if you know, then we can decide whether this is going to be a tautology or not. So P, Q, the first bracket, negation of P or Q. Second bracket, P or negation of Q. Third, negation of P or Q. Make the union of these three things, then you get 2. The first one is T. P is T, true, Q is true. Then P is T, Q is T, T or T is T. Then negation of T is F. Agreed. So P is T, negation of Q is F, TF is T. So negation of P, negation of T, F, R, Q is T. So FT is T. So make the union of these three things, that is R of this R. So F or T will be T. Yes. If there is one T, that is sufficient for us. So because it is T, you have to test for the second one. TF. Then will be T or F. T or F is T. Negation of T is F. So P is T or negation of F is T. T or T is T. And T negation of P is F or Q is F. F or F is F. So you got now one of them is T, that is sufficient for us. F or T or F is T. That is sufficient for us. So try for the next. So in a similar fashion, you will get this one, F, T, T. And for the, again, you have to test for the next one, F, F. So in the case of F, F, now P is F, Q is F, F or F is F. Negation of F is T. And whatever it is they are, 1T is sufficient for us in these three brackets. So the answer is T. So all of them, for all the truth values, the truth value of the compound statement is T, T, T always. So this is T, 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 T. Therefore, it is a tautology. So for delta is equal to R, this is a tautology. We see the next one. So there's a given statement, equivalent statement, and the delta comes from these four logical connectives. And this time, case 3, delta is, we have taken implies. So wherever there is delta, you write implies. And then if you know the truth table for implies, that is sufficient. Now write P, Q as usual in the earlier discussion. So this is the same one. Now we have T, T. So P, T implies T, T. So negation of T is F. P is T implies negation of Q is F. So T, F. T implies F is F. And negation of P, that is F implies Q. Q is T. So Ft is T. So F or T is T. So like that, we have for TF, for FT, for FF. Now let's see for what is FF. F implies F is T. And negation of T is F. This is not T, this is F. This is F. So now P is F implies negation of Q, T, F, T. So this is T. And negation of F is T implies F, T implies F is F. So one T is sufficient for us. And this is not a T, this is F. And one T is definitely be there. That is P. So let's see once again. P, this is F, implies negation of F, that is T. Ft is T. So one T is there. So the union of all these T, this is F or T or F is T. So all these are T's are there, truth values. So this is always true for all truth values. So it is a tautology. Let's get into the last case, if and only if. So this time delta is if and only if. Then if you know the truth table and wherever there is delta, you write if and only if. And if you know the truth table for if and only if, that is sufficient. So let's see. So we have taken the P is T, Q is T, T implies and implied by T is T, negation of T is F, agree? P, T implies and implied by F is F, right? And negation of P is F, implies and implied by T is F, All of them are F is F. So there is no need of going and seeing for the other truth values, and it is F. And what is a tautology? Tautology is always true for all truth values of P and Q. So it is not. So therefore, it is not a tautology. Now let's consolidate. The number of choices for delta belongs to these four logical connectives such that this compound statement is a tautology is 2. Who are they? The logical connective R and implies. For these two, it is a tautology. For the remaining two, they are not tautologies. So our answer is the number of choices for which this is a tautology is 2. So our answer is 2. I am sure that you have understood the solution of this problem, and it is a little bit tedious because you have to put the truth tables for at least 2 of them. It will take time. But anyway, such questions do come now and then. I wish you all the best. Thank you.